Welcome to the Interface Challenge. In this challenge, you'll be working on creating some mappable output. In the past decade or so, maps have become part of so many applications. Everything it seems can be described on a map, and you may need to provide this support for existing classes. Most things, when drawn on a map, fall into three categories: a point, a line, or a polygon or geometric shape. The result of your code will be text that could be printed out to a file for exchanging data with a mapping application. One such file is a specially formatted file called GeoJSON, which is a JSON file extended for geographical elements. You don't have to know JSON or GeoJSON to be successful at this challenge. For this challenge, you'll simply create a string for every feature that will be mapped. An example of such a string is shown on this slide. Notice that data is represented in name-value pairs. The property name and its corresponding value is separated by a colon. Pairs are separated by commas. Values can be string values or a list of values. You can see that here properties is the name and the values is a nested list of name-value pairs in curly brackets. Your challenge is to first create a mappable interface. The interface should force classes to implement three methods. One method should return a label, how the item will be described on the map. One should return a geometry type, point or line, which is what the type will look like on the map. The last should return an icon type, sometimes called a map marker. This could be a black pushpin for a point of interest, or a red solid line for a highway, for example. In addition to the three methods described, the interface should also include a constant string value called JSON_property, which is equal to properties in double quotes, colon, and %s in curly braces. A hint here, using a text block, will help maintain quotation marks in your output. Include a default method called toJSON that prints out the type, label, and marker. I'll show examples shortly. This interface should also have a static method that takes a mappable instance as an argument. This method should print out the properties for each mappable type, including those mentioned above, but also any other fields on the business classes. You'll also want to create two classes that implement this interface. These can be anything you want, but the examples I'll use are a building and utility line. One class, in my case, the building, should have a geometry type of point, and one class should have a geometry type of line. The utility line class will be my example for a class that will be a line on a map. When these items are mapped, the building will be shown on a city map as a point with the icon and label specified, and the utility line will be a line on the map. We aren't actually going to map it. We'd need quite a bit more time for that, but we'll have some of the data elements that a mapping system would need, and in one format that it could use. Your final output should look something like I show on this slide. You should output the geometry type, the icon information, and the label. Here is an example for a building, including type, label, and marker, but also the building name and usage, which are fields on building. And here is an example for a fibre optic utility line. So a line, a green dotted line, would get drawn for a fibre optic cable on College Street. You can see that the properties are a comma delimited list in curly braces with the property or field name in quotes, then a colon, followed by the property value or field value, and that's also in double quotes. Okay, so see what you can do with this challenge, and make sure you have some fun with this. Maybe you want to map towns and roads or parks and rivers. Just make sure one class could be a point on your map and one could be a line. We've covered a lot of material, and this is your chance to explore and experiment with some of it. If you get stuck and want to first look at my design as a class diagram before starting, you can see this on the next slide. After that, if you want to see how I go about coding the solution, come back and we'll go through it together. Pause the video now and give that a go. Welcome back. How'd that go? Did you create some mappable classes which use the mappable interface? Okay, firstly I'm going to show you my design. It's usually a good idea to draw out what you plan to build, at least a rough sketch to start. Here is one solution. On the mappable interface I have one constant, JSON_property, and three abstract methods, getLabel, getMarker, and getShape. I'm also including a default method toJSON, which is going to return a string. This will be a combination of the geometry type, the icon, and the labels printed appropriately for the JSON format. This is the attribute name in quotes, followed by a colon, followed by the attribute value, also in quotes. This method will get called from the static mapIt method, which takes a mappable argument. Notice that the getShape method returns an enum type, geometry, and the valid types on this enum are line, point, and polygon, although I'll only show classes with line and a point examples. I'm going to be using a lot of enums in this example, just to make the code a little more interesting, as well as simpler and easier to read. I'm also going to use enums for colour, and the point marker and line marker types or icons. I'll explain these in a moment. I have two business classes to be mapped, building and utility line, with a couple of fields, name and type. For building, I'll use an enum to describe the building type, how the building's used, for example, if it's residential or business and so on. For the utility line, I'll use another enum to describe the type of utility it is, like electrical or water. I've created a project called Interface Challenge with the usual setup. The first thing I'll do is create the interface in the dev.lpa package, and I'm calling that mappable. Notice in the project panel how an interface has a different icon than a class, a green circle with an eye representing an interface type. So first, my constant JSON underscore property. As I've mentioned previously, when you use a text block, anything between the two sets of triple quotes is included, and that includes any double quotes you specify. Here I want my string that gets printed out to have properties in double quotes, then a colon, then a set of curly brackets. Inside the curly brackets, I'm using %s, which as you probably know by now is a specifier for a formatted string. I'm going to replace that with the actual properties string later. Because this is an interface, underneath the covers, this field is public static and final. Because it's a string, this is really a constant, and I'm using the constant naming convention, all uppercase letters. I talked about this in a previous video, but this is now a public constant, meaning anybody can get this value by calling mappable.json underscore property. I've said we want three abstract methods on this interface, one each to return a map label, a geometry type, and a map icon. String get label parentheses and no method body, so just a semicolon after the parentheses. Then geometry gets shape, again no parameters. I will define geometry later in the video. Lastly, string get marker and no parameters and no method body. A marker is just a map icon. This means I have three abstract methods. On an interface, I don't have to use the abstract modifier. As you will hopefully recall, methods are automatically public and abstract if there's no method body. The requirement said that we should force classes implementing this interface to have these methods, so that's what an abstract method does. A default method doesn't do that. Only a true abstract method requires any implementing classes to declare that method on it when they implement the interface. The only other thing to note here is that the shape method returns the enum type, geometry. I'll create that enum in a moment. Next though, I'll create the default method called to JSON. I'm going to use a text block for this so that I don't have to escape embedded double quotes. Here, the properties I want printed are type, label, and marker. And then I'll make a call to the formatted method, passing return values from our various get methods. This is the default properties string printing out the type, label, and marker. The error for getShape will disappear once I've created some enums later in the video. The property names are in quotes, so you can see type, label, marker. The string specifiers, the %s placeholders, are all also in double quotes. What's notable here is that you can call the abstract methods from this concrete method. At runtime, Java resolves the method that's actually invoked. Even though on this interface the methods like getLabel have no implementation, we can assume at runtime that what's invoking this default method also has these other methods. Finally, I'll add the static method mappit that takes a mappable type as a parameter, and then I'll print out JSON property. This static method is going to first format the JSON property static string. The string that will get replaced will be the string we get back from the toJSON method. If we don't override the toJSON method on our building and utility line classes, then we'll get the label, type, and marker printed there, because it will just call that default method we just created. You can see I can call that default method on the mappable type that's passed to this static helper method. The next thing I want to do is set up my enums to support rendering different kinds of elements on a map. First, I want the enum for the three different geometry types, even though I said we only need to do two for this challenge. I'm putting this enum before the interface in this file, enum geometry with 3 values, line, point, and polygon. As I've said, the thing we're mapping can be either a line, point, or a polygon. Next, I'm going to set up 3 other enums to support rendering an icon or marker on a map. I'll have colours, point shapes, and line types. Enum colour will have the values black, blue, green, orange, and red. Enum point marker, I'll have a circle, push pin, star, square, and triangle for these markers. Lastly, enum line marker. I want dashed, dotted, and solid for those different kinds of lines. Okay, this is a good place to stop the video. We have our mappable interface ready, and I've set up a bunch of enums to set up different types of data, which we'll use to drive what kind of marker gets drawn on the map. In the next video, I'll build the business classes, implement these interfaces, and print out some output. I'll see you in the next video.